Welcome, intrepid souls. It is 8:30 p.m. and we are going to 10. And we're looking forward to your questions. The panels are late, but you're showing your interest, and so we're going to do our best to live up to that. Every year at CppCon, we have a committee fireside chat panel with a selection of committee members, a variety. Some are ones you've seen before, some are new faces. And here we have a mix of folks interested in core language and library. Some are deeply involved in one particular subject area. Some are just broad experts in the standard in the part of the standard they work on. Some have been doing committee work for a quarter century. Some, it's just their second meeting, even though they've been doing C++ for a quarter century and been very prominent in that. So we have an eclectic mix of folks here. And I'm going to start things off by doing a quick introduction so that you may know who they are. Most of them are speakers or have been here at the conference, so you may know them, but I'm going to go ahead with the intros. And I'm going to ask each one, what are like the one or two things briefly that you're most interested in current topics that the committee is working on right now for C++26 or beyond. So Lisa Lippincott, you've done a lot of great work sharing numerics, and you're giving a talk here on contracts because you gave such a nice talk at our last standards meeting that we invited you to give an updated version of it here. What are the one or two things you most are interested in?
Well, contracts, of course. I mean, Daisy is going to mention another feature, and it's a perfectly nice feature too, but contracts are...
Now I'm intrigued. Okay. Timur Dumler, you're one of the chairs, you're the vice chair of the contracts group and have been at this committee for some years now. What are the one or two things, I'm starting to see a pattern here, what are the one or two things you're most interested in?
So I'm most excited about contracts. We've been working on it for a while. I think we're very close to getting it into a shape where we can add it to the standard. So I'm very excited about that. I think there might be another feature that I think is quite exciting, but I'm going to let the next person talk about that one.
I honestly did not ask them for teasers, but now this is getting me interested. Okay, Daisy, you're up. Daisy Hollman, she's the chair of the Ranges Study Group and in Library Evolution for quite some time. What's your one or two favoritist features?
Reflection and reflection. And if I get a third one, reflection.
Awesome.
I mean, it's just going to change everything we do in C++, and it's been so long in coming.
Awesome. Now, those of you who were at my talk yesterday, I did not pay her to say that. I didn't know she was going to say that, but you're going to hear more and more things like that, I think. Thank you. Khalil Estelle, we're looking forward to hearing more and more about the exceptions work you're doing. So thank you for bringing that contribution to the committee. What are your one or two top things?
So since we're talking about stuff that's just within the committee, it has to be contracts and reflection. I know it's a repeating thing, but I am very excited about both of those topics. I do believe it's going to change a lot about how the language is used and can bring in a lot of really awesome capabilities in the future. So.
Excellent. Okay, we're getting some consistency, but now let's look at the other wing of the committee. So next to me, and we sat down in no particular order.
How about you? What are you
I forgot to say, I am the moderator so that I do not have to answer questions and you don't have to hear me talk. I say this every year. So I am not a panelist. I'm here to get them talking and to ask questions.
Herb's favorite feature is consensus.
Okay, you got me. But Dietmar Kühl has been active in the library part of the world for a long time. You had, was it 20 years ago, your own implementation of the standard library that informed the committee, and now you've implemented a sender, receiver, and executors because you just had spare time, and you're so good at developing all these things. So what one or two things are you most interested in?
Well, as you just mentioned, the async vocabulary stood execution. That's definitely my number one goal. I don't care about either contracts or reflection, although reflection may help to possibly implement some of the sender receiver stuff.
Okay, so reflection is the number two. Andrei Alexandrescu, I mentioned yesterday that this is actually your only your second ever committee meeting was in June, so 3 months ago, the most recent one. You've been doing C++ for a few years. Was it like 18 months now, I think, since you learned C++? So, and you've been clearly driving things, and now you're joining the committee working on reflection. What are the one or two things that are top of mind for you?
So to me, C+ is like one of those, people sometimes like they marry someone, they divorce, they marry again, and a couple of times. So my top 3 favorites are daisies. And my next 3 are reflection, reflection, reflection. On a different note, I would invite, the experience is going to be a lot different if you come a bit closer into the middle. So I encourage you to come. I've been once in a comedy show, and the experience is very different whether you're in the back not caring or hanging here and asking questions.
Also, the closer you are, the better we can see you with all these lights. As I get to my last 2 panelists, I'm going to invite you to, if you have questions, we invite you for the rest of the session to ask them. We have a mic here and a mic here, and we'll be feeding off both queues, so feel free to start queuing up as we look at Gabriel Dos Reis, Mr. Constexper, Mr. Modules, and has been involved in many other things at Microsoft now and before that. What interests you most of the top couple of things for you that are currently active?
So imaginatively, it will be contracts and memory and type safety.
Excellent. And Michael Wong, what haven't you been doing in C++?
Am I that old?
Well, no, it's just you get around so much, chairing all of what SG12 has become its own committee with subcommittees, and also doing work on parallelism now, machine learning, artificial intelligence, those kinds of things. So thank you for all the work you do. And what is it that you're most interested in? A couple of things.
Well, first of all, thank you for giving me the opportunity to do it. I think I love doing both the deep specifics, like machine learning. We're doing a graph proposal, which I'm very excited about. But I also do the 30,000-foot view from the directions group, where we try to think ahead as to what are the roadblocks that will prevent C++ from going. So we've been talking a lot about safety, security, obviously, and other things, and how to make the committee work more efficiently as well. Thank you.
Excellent. Well, we're starting to see some queuing. We'll take a question over here. I recognize the man in the Hawaiian shirt, which is not me.
No, it's becoming my brand now, Herb. So I'm also looking forward to contracts and reflection very, very much, but at the risk of seeming puckish, why has it taken so very, very long?
That's an excellent question. Who would like to take that? Lisa, you have your hand up.
My talk on Thursday after lunch is about why contracts has taken so very, very long. I don't want to spoil it, but I'm going to say it's largely a matter of perspectives.
So can I?
There's a great teaser, Michael.
Can I just kind of give an overview, another 30,000-foot view again? We've noticed that features, especially big features, often take a long time. Some of them can take 6 years to 10 years. And that's something we would like to do something to address. And there's a big reason about that, in that when a feature is large, and almost every large feature we had in the past always gets something along the way where a competitive proposal comes in, sometimes at the very last minute. Not their fault. This is the reality of the working world. You might not be able to look at something until somebody says, this is going to go out tomorrow and get voted on. I can name you every single large feature all the time that we've been sitting here. And it's just the way it is. I don't know if there's a way we can make it better, or even if we do, we might not want to. I love to hear what other people think, but we've noticed that trend for a long time. I would say that the longest feature out there, I think, is networking. And I think that's closing up to 15 years.
Excellent. Let's go to Daisy next.
I think on the reflection side, since I'm apparently a reflection girl, I think a big part of it has to do with the fact that C++ has so many implementations, and they're all different. And unlike other languages that have one dominant implementation where you can just implement the feature, evolve forward, and move on, and then all of the other implementations either conform or become obsolete, we have to work at this intersection of what is doable in the implementations of the language that we support. Basically 4 of them at this point, 4 main ones. And these front-end implementations all have different ways looking at the syntax trees and of being able to interact with them, of transmitting information about the abstract syntax tree across the compiler, and getting at that information for the purposes of reflection in a way that will work in all 4 compilers is just a massive, massive engineering challenge that is something that's way harder than it sounds.
How about Gabby, and then I think Timur, you're ready to weigh in?
Raise your hands. How many of you read terms of services of software they install on their machines? Okay. I see 2, 3. Yeah, a lot more than I expected, but yeah. Most of the time, we give up in the middle of reading the text. But for the standards work that we do, we can't. So that takes time. That's why it takes time.
Thank you. Timur.
So I think the reasons for reflection and contracts are probably slightly different. For contracts, my take would be that there's so many different things you can do with them. We did this exercise in SG21. Around the beginning, like shortly after the group was founded in 2020, we had a paper where we collected use cases. Like, what could you use contracts for? You know how many use cases we had at the end? 196. P1995, you can read it. So you can use them for runtime checks. You can use them for static analysis. You can use them for proofs. You can use them for optimization. You can use them for lots of other things, right? And depending on what you want to do, you're going to specify them a bit differently, prioritize certain aspects differently. And we found out that there just isn't a way to make everybody happy and satisfy all use cases at the same time. If you try to do that, you're going to spend 20 years trying to figure it out. So you have to kind of limit yourself to, okay, we want to start with supporting just a subset of that and just getting this or that, but then you have to get consensus on that, right? That you're going to like postpone certain use cases and prioritize other use cases, because otherwise you just can't get everything and make everybody happy. And that's a very, very long process. I think that's why it took so long for contracts. We're still not finished. We still have a little bit of like 3 or 4 things that we still have to kind of get that consensus on. But like, I think that's why it took so long. That would be my explanation.
I saw a hand over here.
So it's kind of funny Timur mentioned this. So there's like an embarrassment of riches as far as contracts go, right? For reflection, it was quite the opposite. There's a dearth of good examples, and I think union to string nearly killed reflection. Like, you know, how many times did you see the union to string example at this conference? Right? It's been twice already, and I just convinced David to remove it from his keynote. Right? Like, everyone, oh, what can I do with reflection? You can print an enum. Thank you very much. I was doing that with macros since like 1 minute after I was born, right? Like, it's not a good example. And there's a history to it. AOP is akin to reflection. It died. Aspect J. Who's used Aspect J? Or okay, one guy in the back, of course. Oh, hi. Hi.
Mike and Gabby had their hands up too.
Who's used Aspect C? Okay, so yeah, no, exactly. So trying is actually is not using. Try it is like is not for me. Who used the mock meta object C++, meta object protocol, you know, so that kind of stuff. So very few of us, and they died. They just like, you know, they died because all they had was logging and union to string and all this nonsense, and we didn't have a killer application. I think now we have.
Daisy, one more time, and I invite folks to come up with questions. If you have no questions, I will make up questions, and we have a few. But please go ahead and queue up at the mics.
From a technical perspective, one of the things that took so long with reflection was this disagreement between a typeful and a typeless interface. And then, I mean, the other thing that came to mind when Andrei was speaking was there's a lot of debate over things that are very difficult to work with, like parameter names, which can vary across declarations in C++. So a lot of legacy.
Thank you. Next question, please.
Yeah, I guess this is also a little bit of a comment more than a question, but it's kind of also good that sometimes things take a while, because it's still not all the industries are still using the latest standard, which is 23. Some and vendors are still not caught up with even like C++ 20 in some cases. So, and when you have a whole bunch of new features come along every 3 years, as like a consumer of those features, you end up still having to learn them and figure out what works for you, what doesn't. So in some ways, I would see that this sort of time to invest in these big features is well worth it. So.
Well, since you didn't ask a question, can I turn that into a question?
Sure.
So I would like to see a show of hands by people on the stage and in the audience. Okay, 2 questions. How many of you have heard sometime in the last decade people say C++ standardization is adding features too slowly? It is too slow. Oh, only this side. Okay. Okay. Next question. How many of you, you know what's coming, have said it's too fast? Or have heard people say it's too fast? Yes. Okay, we have roughly equal numbers, lots of hands for both of those. So thank you for that observation.
So I think it definitely depends on what industry you're in to some extent. Mm-hmm. When I was at IBM, backwards compatibility was a big thing among customers that do not want things to change. They've got things that they ship depending on things that their libraries that they're building. Once I moved into research, all bets were off. We definitely want things, national labs. They don't mind rebuilding things all the time. Google, for the most part. We have somebody who actually works for Google. No. Okay.
That's a really awkward comment. We'll
Sorry.
have to talk about that.
But you're right, there's a variety of domains.
Different
and use
companies
cases.
definitely have different requirements. The embedded world space are almost always at least 2 spaces or 2 releases behind. Yeah. By necessity, they have to get their stuff certified, and that takes time. And in some cases, it needs to even be binarily API certified. That means the code has to be checked on a binary level, and that makes it really difficult. So that's why I think different industry definitely requires.
And Gabby?
So I actually have a question for the panel. Why do we think we need to ship features every 3 years or so? Is it just so we stay relevant, or is it because the world is moving and we need to adapt?
Well, I'll take that. It's if we don't ship them, they pile up where they are, and we don't want to deal with the pile of unshipped features.
Dietmar?
Yeah, I would have the same comment based in a sense, like the train is full at some point, and some trains are overfull in a sense. C++ 26 may be one of these trains, which has so many stuff in there that it's a big learning curve to get on that. Hopefully the next releases have less.
I'll just make the comment that shipping regularly is mostly for predictability. The trains can have almost nothing on them. That's okay too. It's our choice what to put on, but it's about predictability. I have noticed since we've been doing that the compiler vendors have been tracking the standard much more closely because they believe us now that we're going to ship. Andrei?
I would add that when was the winter of C++? What decade? What years?
The what?
The winter of C++. The worst period of C++.
The 2020s.
95. Okay, post-standardization. It was 2004 up until 2011.
Pretty much.
That was it. And it's really like maddening that was the period when the whole frequency scaling had plateaued. So it was a great opportunity. So this whole complacency, not releasing, not doing new releases, not keeping people interested, not doing all of that. And there's, we have a C++ 98, the standard, we're good. C++ 03, we're great, and let's do nothing for the rest of our careers. That was a huge mistake. And I think this whole thing with 3-year releases, it's been a great undoing of that winter.
Oh, I see more hands. Dietmar and then Gabby. Any hands over here?
Okay.
And then we'll go to the next question from the floor.
Together with Herb, I was there in that winter. we were not sitting on our bums and do nothing. We put in contracts, we took out contracts. we put in move semantics and nobody understood it. And then there were things where we basically said, all right, we do not ship before certain things are ready. So the committee was busy, but we didn't have the train model back then to say, no, we just ship now what's ready.
Yeah. Sorry, I was earlier mentioning 95, which was mostly before many of us here. I only joined in 97, so why am I talking about 95? Because I've read a lot about it. The committee was actually supposed to ship the first standard version of C++ around 94, 95. And then came this guy with this very strange library called the STL. And it was so revolutionary that the committee thought, well, we don't actually think we can ship the standard without this thing in it. And they delayed by another 3 years, and then we got it in 98. But I'm actually glad they delay, because that completely changed how people used C++, and part of why we're all here.
Excellent. Thank you. Next question, please.
I guess you've spoken about this, especially in the context of reflection and contracts, but I was wondering if you could speak more broadly about what does it look like from the ideation of a new feature and then its inclusion into the standard? Like, what does that process look like in general?
Daisy, you want to start us off?
It can vary with the complexity of the feature quite a lot, I think. There's actually kind of this curve where a very simple feature like sign size is an enormous amount of work to get into the standard. And a very complicated feature like reflection is an enormous amount of work to get into the standard. And somewhere in the middle, there are things that just fly by all the time. But for a big feature like, let's say, executors, the first executors paper was 2011. The ideological great-grandchild of that paper is going potentially into 26 if it doesn't get ripped out. And it's an iterative process of somebody brings something, we talk about it, and eventually someone brings something else and says, I think this is a better alternative. Did you want to actually talk about the specific steps of study groups and then?
You heard the question. Go ahead.
Well, I mean, I think you're the person to talk more.
Oh, but I'm not a panelist, so you need to answer the question.
He's evading the questions, so.
I mean, yeah, somebody else can talk. Okay.
Yeah. I see Lisa and then Gabby and Michael.
First.
Okay.
So I think I've worked on quite a few features on C++ by now. I'll talk about personal experience. The way I look at it is just when you're doing day-to-day programming, don't just settle for lowest thing. And look at how you can improve. What is it that will improve the solutions that you're writing as code in your program? How would it look like if you had access to that feature, right? Because that now you're having something coming from actual work. And then try to turn that into an abstraction. Talk to your colleagues and say, hey, what would it look like if we had this thing? So a concrete example would be constexpr. I was a little bit annoyed by all the macros that I see in codes and what people do, and they're powerful, but not powerful enough to solve my problem. So I sent an email to Bian and say, hey, I think we could do something different. And he said, yeah, you think so? And then he asked me a couple of questions. I was unable to answer those questions. So I went back to the drawing board and I said, oh, actually, I think this is what it looks like. And so it's okay, write it up. And I wrote up, and in the summer of 2003, went to the C++ standards meeting in Kona, October 2003. So this is another step. So when they explain what I think will happen, and a lot of people I respect a lot look at me like, "Are you okay?" Because the notion of asking the compiler to evaluate a function at compile time back in 2003 was, I would say, alien technology. So they're like, are you okay? But don't give up. Not just because an idea is new means that it doesn't make sense. You have to keep at it. You have to take in the feedback and iterate over the idea. Most of the time, you'll get feedback that are actually very good. These people are very smart. They have been doing this for a long time, right? And coming from different perspectives, they will give you feedback that helps you refine your idea, because the first idea might be great, but not that good. Okay? And then just keep at it. And it took about 10 years to actually turn it into real thing that we are enjoying now.
And just to clarify, I think what you just said is that it's mostly your fault that every C++ compiler now also contains a C++ interpreter.
Guilty as charged.
All right. Lisa, and then Michael, please.
Okay, I'm going to signal my age here. How many people in the audience are familiar with the song, "I'm Just a Bill"? So you have a catchy tune in your head and a reasonable idea of how this works. Things move through the standardization process as bits of paper, or at least as PDFs or whatever passes for paper these days. And it's really quite striking at first to realize that it's not about programming. Standardization is not about programming at all. Standardization is about editing an enormous document and convincing other people that the changes you want to make to that document are good changes. So you write papers, and the papers have things like change this word, delete these words, replace them with these words. And you talk to people and you convince them that your idea is good, and then the papers are circulated and they're brought, and you go in front of a subgroup of the committee and you pitch your change and walk them through, this is what it's going to be like. And they read the words and they say, oh, these are, yeah. Maybe you get them to agree. They vote for it if there's a strong consensus for it, and we only move forward with a pretty strong consensus. Then you get to go to a different group and they say, these words don't express what you meant here very well. And you should use different words to say the same thing because those words are unclear. And they make you go back and rewrite all of your changes. And you do that a few times. And then they say, okay, these words actually do say a thing, and you hope you didn't get the people in the first group mad in the process, but you may get sent between, I've had a paper that was being sent between 4 different groups in cycle, and and towards the end, it was very quick. I was like doing a revision every day during a meeting. And towards the end, it was like I did 4 revisions Friday of that meeting and made it as the last paper accepted in that meeting. But that's how it is. It's all about papers and words.
One more, and then we're going to continue with more questions.
Okay, so I'm going to fill in the words that, thanks to Daisy pointing out that somebody should mention what the procedural aspect is. And since Herb is silent, this is my best chance to talk over Herb. I'm going to grab this completely. Okay. So folks along here have already mentioned the inspiration stage. There's a gap, there's something you want to do better. That's your proposal. That's your proposal stage. Then the initial proposal gets written, and then it goes to some study group, especially if it is some specialized things that requires the study groups often house the experts in reflection, on machine learning, on contracts. Then after that, we wanted to exit the study group and then goes to either, depending on whether it's language or library, goes to either a core working group or the library working group to get technical feedback. No, sorry. The study group gives you technical feedback. The core language and library gives you feedbacks about how it fits in terms of standard reads. Okay? And then from that point on, if it passes that, then it goes to plenary. Now, I noticed Lisa raised her hand. There's a cycle there that happens where it might keep going back to the study group, comes back to the working groups. That is like an internal cycle. After that, there's still a lot more to go. It's going to have to go to plenary. If it gets voted in plenary, then it goes to national body review. There are national bodies here in the audience and up here who has to approve. And at some level, that's possibly the last stage at which you can oppose something. Okay, and then after a national body review, there's multiple stages of the standard, which we don't have to go into, that it still has to escalate through. There's comments, technical comments, and then there's a final stage when there's no technical comments allowed, just an up-down vote with editorial comments. And that is a long process of standardization. And the thing that I want you guys to take away from this is that it sounds long, but the point of it is that we double-check each other. Our thoroughness, and honestly speaking, despite that thoroughness, there's still things that get out, but that's okay because we have an equally, even more rigorous defect processing process. That is even more rigorous to make sure that we can correct things that go out that might have ambiguities or incorrect things that we don't want to do. So that is the thing that Herb cannot say. Thank you.
So I saw last week that the C++ Alliance had put their weight behind Sean Baxter's new proposal about adding a borrow checker and lifetime annotations. And I was wondering, obviously that proposal needs time to cook in the committee and go through study groups and all that stuff. But I was wondering if anyone in the panel had any opinions on that work, and if not, if there were any other memory safety proposals that people were excited about.
Oh yeah, I did read the proposal. I thought I should do my homework before flying out. Herb, not speaking, would say something like this. Oh, let's assume that we have this uncontroversial proposal. Let's add garbage collection to C++. Everybody will, will jump out, right? So I guess what I'm trying to say is when we're evolving a language. We are not inventing new language every time. Yes, we have a new standards, but most importantly, we are evolving the language. And evolution means that we accept what exists and we are trying to move it forward without breaking too much existing code. Because, if we break a lot of existing code, the community that we serve, they will be very, very mad at us. They will probably vote to retire us, right? So I think the proposal that is put forward, Safe C++, is from intellectual perspective, really nice work. It shows you how you can graft Rust ideas onto C++. The real question is whether it is viable in the environment where C++ is used. And that's a much, much tougher question. So it hasn't been implemented yet and deployed yet. So at this point, we are all speculating about what it might look like if it gets dropped as a compiler in the environment where C++ is used daily basis. My personal opinion, so at this point, it is not science, it is more opinion, is I am not that positive about it. Like, I'm not saying zero. I'm saying the chances of it's not taking off like wildfire is not that great. It doesn't mean that the idea itself is wrong. No, that's what it's about. You can have a great idea. Question is, can it catch fire in the environment where the language is used? The other thing is that C++ has been successful not because it is 100% right on every single thing that it is trying to address, but that it has been able to be, okay, on sufficiently enough of those features that when you put them together, you actually have a workable solutions where each of those competitors that try to achieve perfection failed, right? It's really practical use perspective. So there are other proposals out there trying to address safety. One of them I'm guilty working on is C++ profiles, which is trying to say, okay, here is where we are. These are things that we have today. And given that we cannot just break everything, how can we move from where we are to a place where when you enable that feature by default, it will prevent you from making some of these common mistakes that we all make. It's not a matter of being expert, just a matter of programming, and at a certain rate, some errors just come up, right? So memory safety, type safety, bound checking, arithmetic safety are those things that I've been working on with Bjarne Strostrup. Herb, who is not talking, also has ideas. And it is really trying to do this in a way that encourages gradual adoption.
So I'm seeing other hands. However, it's an excellent question, but I'm going to dedupe because it was asked and answered by quite a few people last night at the safety and security panel. So I'll refer folks to watch the video of that as well. But excellent question, and we got some coverage of an answer here. I'm not sure that mic works, so feel free to go over and join that queue. We now have one queue. Oh, okay. We're going to give you a new mic, and if you can share that mic over there, thank you.
Thank you.
Awesome. We would share our mic on the end there, but there's only one of him. So
yeah, as long as
that was a joke about you, Mike. Go ahead.
Okay, that was actually a great setup, that question for this question, because I was thinking of this a lot at yesterday's panel. But it does apply for what we're talking about tonight. Actually, it applies more. We were talking a lot about safety, and the term was used a lot around memory safety and type safety. But also sometimes we talked about functional safety. And I was a little queasy that we lumped those together because sometimes memory safety, particularly, and functional safety are in direct conflict. I work in aerospace, and one of the things that I've heard from regulators when looking at C++ as a choice versus, say, C, is the visibility of the code. They want to see lines of code written down and have an accounting for what you intend and the effects that has at the system level. So my question for the panel is, when you're thinking of, when you're specifying these new features, contracts is an example that has some runtime components to it. Is there any consideration about the magic that is inserted into the binaries and how that magic can make C++ less desirable as a language for high criticality systems?
Thank you. And if you can just park that mic there, since we know that one works. Thank you. Go ahead, Lisa.
So I'm grabbing the mic here because dinner tonight was largely consumed by just such a conversation between me and Timur. This was particularly, we were focused on the, basically the space between a coroutine declaration and the coroutine's body, which is larger than you might think. But yes, we think deeply about these details, and we don't like to hide things from you, but we don't like to make things excessively difficult to use either. So there are compromises made.
Okay, one thing I want to say in that direction is I'm not aware of that many people from a corresponding space on the committee who comment on, oh, that is a problem in our regulated world. Can you make it so that it actually works? So we may want to get more involvement from that community to actually make it so that we pay enough attention to it.
Mike and Gabby?
Yeah. So I actually work in functional safety with autonomous vehicles, 61508 and 26262. So this is actually, there's something that's occupying my mind for quite a long time. So functional safety is broader, okay? It's talking about ensuring the safety, especially in critical environments when faults occur. Most usually, especially when harm can be caused to human life. Memory and type safety is all about software correct. To many extent, it's all about software correctness. And it's something that is a desirable feature for programming languages. Functional safety is a legislated thing by law. You have to have functional safety in critical safety systems. Okay, so I think that the concern here is that they do build on each other. It seems that when, one thing I was struggling to say yesterday, but I wasn't allowed to talk yesterday either, was that people focus too much on safety at one particular level. It's not true. Safety is an overlapping layer. When you talk about functional safety, you're not just talking about software. Of course, in today's autonomous vehicle world with software-defined vehicles, large part of the vehicle is software. But in the old days, they weren't. They were ECUs, electronic control units, control systems, and motors and braking systems. All of those have safety concerns. When added together, makes the whole system functional safe. Okay, so you need the safety of the software, you need the safety of the ECUs, you need the safety of the braking systems, and they all have different amount of consequences called ASO. So that's why everything leads to some extent to functional safety, but only if you're working in a life-critical system. Okay.
A quick addition, and then we'll take the next question.
Yeah, so Mike said most of what I was going to say. The other thing is, yes, hidden cost. I don't know anybody here who likes hidden cost, right? So we think a lot about those things. And there is a balance to strike between, we need to make everything that has cost explicit so that it is obvious when auditing and so forth. But when you ask people to write everything, there is also a chance that they might forget something. So it becomes, what can we automate so that there is absolutely a guarantee that the writing happens? And then what is so costly that it should really be obvious what's going on?
Excellent. Great question. Next, please.
How you guys doing? So I work in definitely life critical safety systems, embedded systems. So in February, as I'm sure you're aware, in February, the White House released a press release that basically said the community should move away from C and C++ due to memory safety and start moving towards Rust. I work in an industry that where the White House press briefing has a huge impact and bearing on the direction that a lot of my programs are going to then take. So within that context, especially then with what was already said, where a lot of times embedded systems are two versions sometimes behind on the standard, what is being done today to try to mitigate some of those risks and concerns that the government has to not just memory safety, but all safety, to make sure that it's a language that's going to continue to be used in those spaces?
There can be easily a 60-minute answer to that, so we'll try for a short one. Gabby?
Yeah.
Great question.
Yes, like you, I have been following those press releases from the White House and federal agencies quite closely. The first thing I wanted to say is the idea of rewriting everything in Rust is a meme. Sure. Okay, it's a meme. I'm not here to defend C++ at all costs, but just state fact. I work with people involved in Rust very, very closely on daily basis, and they will say the same thing. The other thing is that the C++ community really, really need to wake up and understand that the C++ language is a fundamental infrastructure mean to the modern society and takes into account the impact of its output, what we do. And I think regulators and White House things are a way to like put pressure on us to react in a responsible way. Okay. So the second thing I will say is that I'm trying to find it right way.
Well, while you're thinking of that, we have Khalil and then Mike.
So I also like interact with the subgroup in the committee for safety. They take a lot of the stuff quite seriously. There are a lot of things that the committee is looking into, one of them being profiles, which I think is going to, so long as profiles end up being the solution or we find something else akin to that, we are always considering ways that we can improve the safety of C++ for embedded, for safety critical stuff. Even the research that I'm doing in exceptions is actually to make exceptions viable in safety critical situations. In my opinion, this is me kind of touting the technology I'm trying to build up, is I can't get the insight about my locally handled errors, but I can do that with exceptions, at least a little bit better than I can with locally handled errors. I think that there's a lot that C++ can do, and we will continue to grow in order to be safer in those areas. And I think that all this press releases do is push us and put a fire underneath our butts to do something. So I think we have been. Give us some time.
Sure. Just one quick follow-up, right? I know we talk a lot about profiles and contracts. There is, one of the pitfalls that I see almost on a daily basis is there is so much undefined behavior within the C++ language. And a lot of that, I'm not going to say all of it, right? But a lot of that could potentially be kind of quick kill things to start to mitigate some of those safety concerns. So is that anything that you see as part of that subcommittee?
I see lots of hands that you just triggered, so.
Yeah, so it wasn't that I forgot the word. It was trying to find a politically correct word. So I was just trying to say that the C++ community shouldn't be complacent. That's the thing, and the White House press releases are actually lighting the rightful fire under our rear. Okay, so on the undefined behavior thing, yes, I agree with you. We should really minimize that, and there are work being done, especially in C++ 26 and forward. But don't forget that not all undefined behavior are the product of laziness or lack of imagination. Sometimes there are real technical issues behind those things being undefined.
Quick follow-up in a few words. How much undefined behavior is in context per functions, language undefined behavior?
0.
Gabby?
Yeah, 0.
0, thank you. We can do more of that. Timur, then I'm getting a crick in my neck. And then Mike.
Yeah. So I think to address things like undefined behavior, there's like a few really complicated things that I don't think we quite know how to tackle yet, like memory safety. How do you make sure that a pointer always points to a valid object? Like the borrow checker is one solution, which is a big thing, which we don't know how to integrate, right? There's other approaches. That's a complicated topic. But there's also quite a few like low-hanging fruits, which we are chipping away at. And I think that's an ongoing process that we've made good progress on. In C++ 26, it is no longer undefined behavior to read an uninitialized value. In C++ 26, it's no longer undefined behavior to have like a trivial infinite loop. And I'm sure that the plan is to just gradually chip away at those things as well, where there are low-hanging fruits where there is something that is undefined behavior today that you can replace with either detected at compile time or replace it with some, as you can now call it, erroneous behavior, which is no longer undefined. So I think the big things like memory safety, type safety is one thing. We have profiles, we have these other approaches, but there's also these little things that we keep chipping away at. And I think we need to maybe get that message across that we are continuously doing these things, and each one of them improves, takes away some of the UB. So that's also ongoing work.
The consumers are not keeping up with the producers. And so a really quick take and then next question.
Okay, so the directions groups have obviously discussed this for quite some time. And our strategy is certainly looking at those edicts. Looking at those edicts, number one, we've noticed that most of those edicts were made without C++ involvement. That was certainly one thing. And there are many other things, but I won't get into it. But a safer C++ is not just one particular feature. Contracts, maybe one way. Profiles, which gives you guarantees, another way. C++ and strengthening the C++ core guideline, and maybe MISRA, which allows you to run automated checkers, is another way. Ours is a multi-pronged strategy. And then there are other strategies like toolings, like ASAN and MSAN and the client static analyzers, as well as having the C++ language features like unique putter, share putter, and RAII, strengthening those things. We definitely have to, the other thing is we definitely have to work with the regulatory bodies on DO 178C, 26262, 61508. We need to work with them to show that, and many of them actually use C++ as the initial base. We need to work with them to make sure that we can strengthen and prove to them that C++ is not the beast that the government says it is. And I can point out one thing. Just because the government says something is good or bad does not make it succeed or fail. Look at Ada. Exactly. A military language designed for the military. How many people uses it now?
Well, you're asking a C++.
Thank you. There's more, but I think that's the three-pronged strategies that we've been discussing in the directions.
I will take one more because Andrei's been quiet and it looks like he wanted to say something. Okay. Next question, please.
Hey, so the C++26 reflection proposals adds a lot of meta functions to reflect information about the type, but what about reflecting a function's body? Things like scopes, control flow, elements, or expressions, because it can have many useful applications like compile time static analysis or automatic differentiation.
Did you call yourself Reflection Girl? So
I guess. So it's a lot more complicated, right? The loops of this depends on this, depends on this, depends back on the original thing are much more complicated when you start involving expressions, which is why we can't even reflect on expressions in 26 yet. Or we can't reflect on anything in 26 yet because it doesn't exist. But the current proposal that is making progress moved reflection on expressions out of the initial proposal, because there's a lot more complexity to that. The other thing I will say about that direction is that like C++, compile time C++ is a language that you want to be using instead of template metaprogramming. It is not a fast language for parsing C++ itself, right? You are not going to, like, interpreting C++ at compile time is still very, very expensive. It is cheap compared to template metaprogramming, but it is still very, very expensive compared to languages that are built for to be interpreted. And it is very expensive compared to runtime C++. And so going all the way down the road of doing static analysis of function bodies with compile time C++, constant spur functions, is not likely to be very efficient. Doesn't mean that we won't have people who will try it if we ever give them the tools to do it. And I certainly hope we do, because C++, like, there are bad things to do in C++, and that's just reality. Like, you can write bad code in C++. But I don't think this is the static analysis feature of the future. I don't think reflection is how we are going to statically analyze code to make it safe. I don't think reflection is how we are going to statically analyze code to augment it with other features or automatic differentiation. I don't think we're quite there yet, or don't see that on the near horizon, just because the interpreter is so much slower than like a dedicated language built right on top of C++, on top of the source, or a precompiler of some sort, or a static analyzer through like Clang tooling. Those are all going to be so much more efficient than trying to take a std meta info that has a function body in it and like iterate over statements and figure out what they all do and figure out what's going wrong. I personally would at least have that objection and have to have a really serious answer to that objection before I would support such a proposal.
So I'm going to direct that question also to Andrei, because you have an opinion or two about reflection.
I think with regard to this particular feature, it's time to pay the piper, right? C++ has a very rich syntax. And, you know, in the back of our minds, we did have a notion that, well, one day we're going to pay for that, right? And this is the day. We're paying for that in the sense that the syntax is so rich that it's prohibitively difficult to do any meaningful manipulation of it. If you look at the kind of work type checkers do in Clang LLVM, you're going to see that they almost never, to my knowledge, and you know, I stand to be corrected or amended by you all. But essentially, my understanding is that almost never they work on the original AST. They always simplify the code to some form, some internal representation that is more amenable to analysis, and then they run the analysis on that. The notion of analyzing source code to a meaningful manner is, as Daisy said, quite foreign and unlikely to come to pass. Also, I have mixed feelings about bottom-up design, like, you know, let's do a little now, a little later. But in this case, it seems unavoidable to me that you gotta put in the standard a few things that are gonna increase the courage of people to like, actually, you know, I could live with code that generates code. Because that's something that I notice like really scares the living daylight out of people. But once that scare goes away, maybe they'll be like, wait a second, I want autodiff. I want the nice things.
Thank you. Great question. Next, please.
Hi, everyone. Hi. So sometimes when we write a proposal, I mean, the experience of writing it can be about conveying the idea and convincing people to vote for it and showing the advantages of it. And that's kind of a near-term or a present thing. But sometimes a proposal can serve another purpose, which is to engage in dialogue with other programming languages. So I see some proposals react to or respond to features in other languages, comment on them. And there's a sense in which proposals are for the future. Like even if a meteor hits the CppCon and C++ doesn't exist, but our proposals are still out there, 50 years from now, someone may read them and be inspired by them. How would we write proposals differently if we had that in mind?
Rephrase, make it
Could you rephrase
simple.
the question?
Sure.
Explain me like I'm 5.
So like, you're always a child at heart. Aw. So imagine like, there's the purpose of a proposal, which is to convince the committee of an idea. And when it's voted into the working draft, then the work is done in that sense, right? But there's another purpose of the proposal, which is to communicate an idea to the future and to communities outside of this community. And if we wanted to do that, more of that, how would we write proposals differently? How should we write them differently? Is that okay?
Yeah, so proposals are for moving the current standard forward, and for how much should they be for posterity, for the corpus of human wisdom?
So, okay, I got it, and thank you for rephrasing and clarifying. Yes, I agree with you. Many proposals are about changing the standard current draft to something else. But sometimes when you look at some proposals, they actually try to do this thing we call explore the design space. Exploring the design space is communicating ideas about what exists today, what could possibly exist tomorrow, and then making some kind of balanced decision. But during the exploration, you also actually communicate ideas about what could be done tomorrow if these other pesky realities didn't exist today, right? And I've seen that in quite a few proposals in the past. Some of them will just go, yeah, that doesn't make any sense, until you realize, oh yeah, actually it makes sense if you sit down and don't just think about the current realities. And quite often when I read proposals from Biane, many of them are position papers, and some of them like really go in there and explore the design space, and then say, oh, okay, by the way, we have these pesky realities because of those things. We need to make these choices. But I'll encourage you to look at those proposals. There are quite a few of them. Sorry, from the top of my mind, I can't give you, but look, the Alliance proposal, they systematically try to explore design space and position papers.
Very nice answer. Thank you. And good question. Next, please.
I've spent my career in the video game and embedded fields, and I started in '95 with C++. Const eval, const expr have been just tremendous benefits. I'm excited to use reflection. There's been a lot of love for the compiler, but what about the linker? Are we ever going to get a link expr function? Variables, because I want to run through all my translation units. I want to find certain variables, rip them out, smush them into an array, get rid of all my static initialization before main. Is that on the table?
Khalil and Gabby seem to have something they want to say to you.
Just personally, I think a lot of the work that I'm doing is predominantly at the linker stage. I think there's a lot of things that we can do. I also want to investigate more of the other linkers that I found online, like Mold, the modern linker and stuff like that. A lot of the optimizations I want to do for exceptions requires, I don't need to look at the compiler. I only need to look at the linker. The linker is the sole place where I'll get all of my work done. So I think there's going to be, I personally am invested in improving the linkers and improving how code is formatted or arranged. And, sorry, one last thing. There's a project called Bolt from Meta that is about rearranging your binary in order to improve performance and that kind of thing, or changing certain things to improve performance. So I think there's stuff there.
Excellent. Daisy and Gabby?
I think we would need to start with the standard acknowledging the existence of a linker. and that is long overdue. But it is a massive project, and it's a thankless project, and you're mostly just going to get people coming back to you with well actually, and you need a lot of well actually patience, and that's a really valuable resource.
Do a very quick comment before we can acknowledge the existence of linkers. We have to acknowledge the existence of source files, which is even harder, I think. So it would be quite an interesting project.
So at the risk of disappointing my friend panelists, actually the standard does acknowledge the existence of linkers, source file, and all those things. Just have to look at the translation phases description. Going to your point, yes, I'm guilty for pushing for const expr, and then that push all these old things. During the C++ 20 cycle, I was trying to push forward the idea of, we have compile time, link time, load time, and runtime. We should verify those phases and have a unified description for those things that happen, those things. I am there with you. I really want to have those things, but there's so much that I can do or anybody else can do. So if you could write a proposal and have someone advocate for you, I'll be there, rooting for it.
You just got applause for most of the panelists, so thank you for that.
It's a deal.
Okay. Next, please.
So there's been a lot of talk about UB and type safety, but I've noticed, and this is not a criticism of the presenters or anything, but I've noticed over the last couple of days, a lot of talks have examples of UB and implementation-specific behavior in them. So my thinking is that we don't want to promote the rank and file C++ programmer to have to resort to implementation-specific behavior just to get their job done. And to that end, what are we doing to address some of these things that we see even in our own presentations? One that comes into mind, I see it quite a bit. Do we have anything we could or should say about type punning?
Andrei.
So, okay, it just so happens, I just read this Wikipedia page about it, and I forgot the name, but there is a phenomenon in psychology, which is once you see something, then you see it everywhere. I forgot the name. It's like, it's a proper name. So Hollman, what? Okay, always people with the answer are in the last row. Literally, he's in the last row. Okay. So there's this phenomenon, and once you see something like, oh, wait a second, so there's this thing happening, and then you start seeing it everywhere. Presumably, at past editions, there's plenty of unsafe code too. I give you money, right? When you say type punning, you mean this like union style interpreting the verb, right? I would say just it's good that you raise the question. I don't think there's an answer beyond because there's been a lot of answers about how C++ wants to improve safety in general. I would say, tell the presenters, get up and say, this sucks, I'm leaving.
Direct answer. Excellent. Next question, please. Oh.
Can I just comment on this? Because I wrote a few papers on this space. I did some work there. And to give you just one example, there was one thing I was working on where you can take a variable like an integer and like cast it to a char star and then just loop through the bytes. You want to implement like a, I don't know, hex editor. You want to just look at the bytes that this int is made of. And it turns out that's undefined behavior. But every compiler, like if you just write, int, reinterpret cast to char star, print out the 4 bytes, every compiler does the obvious thing. It obviously works, but it's UB according to the standard. And I spent a lot of time trying to find wording that makes that do the thing that everybody knows it does. And it took like, I don't know, 6 or 7 trips to like the wording group. And at the end, I just gave up because I didn't know how to do it. So just one story in that space that I felt was relevant.
Yes. Yeah, I will say I've actually been in the talk that Andrei was talking about where somebody gave a talk that that hinged on things being layout compatible that were in fact not layout compatible. And so what I did, well, I had the misfortune of mentioning this to Marshall Clow, and he said, you should fix that. And so I wrote a paper and took it to various committees about how do we actually inform a programmer when 2 things are not layout compatible? And now we have a library function, is layout compatible, that will test for that. So that's how it happens.
Thanks for being part of the solution. Very good. Next question, please.
Hi, I think we previously mentioned there is a gap between a feature, a language syntax is getting approved as a proposal, and then there's numerous compiler vendors needs to catch up on implementing it. And I also guess, don't quote me, but I guess C++ is the most famous language I know that doesn't have a prevailing, the dominant compiler implementation. How crazy is an idea, and we have a standard committee here, how crazy is an idea that we standardize an implementation of all the language features and syntaxes here? Or is that going to be an endless debate on which basic compiler, the prevailing compiler we have currently
I see lots of hands wanting to answer your question. I'm trying to take one that hasn't had as much opportunity. I thought I saw you, Andrei, maybe Daisy and Lisa.
Thank you. I'm sure Gabby would have a lot to add as well. But let me tell you experience coming from a different community. So it went like this. Initially, the D language had 1 compiler. Everybody say, why does D have only 1 compiler? And that will be the standardized compiler and everything. And then it had 2 and 3. And everybody was like, why does it have 3 implementations and not just 1? So wherever you are, the grass is greener.
Excellent. Daisy and Lisa?
I mean, I think this is something that I've said at every one of these panels that I've been on is exactly what you just said. And I don't think that there's a way out of it, to be clear. Like, there's too many business interests in at least 3 of the 4, no, all 4 of the 4 compilers. EWG also does great work. And it's like reference implementation, we're not funded for that. Like the committee is barely funded to put out a PDF every 3 years. And that's even quite hard. And we're not funded, it's volunteers, right? Like if there were some set of companies that had an enormous amount of money to put behind this, I could see it happening. But like even then, there's probably some anti-collusion issues.
Dietmar and then Lisa.
I think competition is also good. That's basically, there's a race on who's first and they go there. So, and when they say, oh, we have that feature out, I have the impression all major 4 compilers are basically ready with the next revision of standard, except for really complicated things which often are not actually inside their control. Like modules or something which needs a build system around to actually make it work. This is why some compilers have not done it yet.
Lisa, and then I predict Gabby will say something that includes the word monoculture.
Well, I'm going to come right out and say diversity is our strength. This is what makes C++ a better language in many respects, is that we do have a diversity of implementations and we do have to write a standard to get people to agree with it. The official language is not what one vendor does, what one compiler does, what the king of C++ says. The official language is what we all come together and agree upon. And doing that work and doing it carefully happens because we have a diversity of implementations.
So as the mic is on its way to Gabby, I'm just going to say, exedutils.
So, Herb, you're a psychic. Yes. Actually, if you look back, like, let's say 25 years or more, there were more C++ implementations than there are today. So maybe your wish is being, is coming into reality. We're reducing to 4 or 5 implementations now. Herb is right. I will rail against monoculture. I've worked in my professional life on 4 different compilers now. I started with GCC. When I was in academia, I also worked on with client and EDG, and then in my Microsoft work, I've been working on EDG and a Microsoft compiler. So I have about 4 different compilers I've worked with, and the code bases are different, the idea is different, and the thing I can tell you, for having worked on features and implementing them, is that the diversity of implementations are actually a great strength for the C++ community, and they should embrace it as opposed to seeing it as an impediment. Like if you're a manager somewhere, you want to reduce costs, like, hey, let's just have one and not worry about these pesky compatibility things. But that is actually, from my perspective, a wrong move to make. It is welcome, the diversity of opinions and ideas. And because during the entire history of the C++ standardization process, we have had different implementations. We have been able to refine the original proposals to actually make it much stronger. Things I was involved in, outside Const Expert, there were things that I did not foresee, and just being able to put in front of those things, make it better. Outside modules, yes, I had something that was working with MSVC, but being, confronted with, oh, here is actually how we do things in Clang or GCC, made me realize, oh, I forgot about that aspect. And what I realized was the end result was much better than what I had before. So we should embrace the diversity of thought.
Excellent.
Can I say 2 things quickly? Yes. Okay. In addition to the diversity.
Excellent question.
Monopolies stifles innovation, okay? And that's going to generally lead to slower development. And then the next thing is that it also leads to bottleneck in development. So if there's any bug, security features, that's going to pervade the whole industry if everything comes from one compiler. That's all I'm going to say.
And I was trying not to comment, but the reason I said exedutils is because if the entire world was one C++ compiler, you could take it down with a single successful supply chain.
And that has happened recently with that thing, which I'm not going to talk about.
Yeah, I would know anything.
One word to add.
Pearl. And with that pearl of wisdom, we have 3 more in the queue. That will be the end of the queue as we're getting close to wrapping up. Next, please.
So clearly the White House should just mandate we standardize on GCC, right? But anyways, real question is, you guys have had a lot of really tough questions tonight, and I'm going to ask you the hardest one of all. Coke or Pepsi?
Coke or Pepsi?
Okay, Coke, Pepsi. There you go. Softball question.
Thank you.
Yeah, that's right. We used to have cherry Coke represented, but we still do it at quite a few meetings.
Okay, this is a human interest question. I think it'll be harder for some of you to answer than others, but I've been serving on the committee for about 10 years now, and my opinion of the committee changed after I joined it. And I wondered how all of your opinions of the committee might have changed after joining. What did you think of the committee before you joined, and what did you think after you'd seen how the sausage was made?
You took one of the questions I was going to ask at the end. You are also psychic. Excellent. How has your view of the committee changed from your first expectations to now that you're in the thick of it? Lisa, Daisy?
So I think I've already mentioned that perhaps the most striking thing to me was how little of the committee was about programming. That it's a different process. It's about paper.
I think I'll say the biggest thing that's changed for me is that I've burned out and then come back and then burned out again. And I think that you get used to those cycles, but I definitely am not like the first couple of meetings I went to, probably learned a lot. But after that, I think it's been the kind of minutia and technicalities that I expected it to be. And I love that. And if you love that, you might enjoy coming to a committee meeting.
Cute. Mike?
I would say that I'm going to give a comparison, having been on 4 different committees now, different ISO committees now, C++, autonomous vehicles, functional safety, machine learning, and another one which I don't even remember now. But I think C++, of course, when I came in, I was overwhelmed, blah, blah, blah. I didn't talk for 3 years. You guys noticed that. And then 3 years later, I couldn't stop talking. But now I would say that I'm more impressed than ever by the C++ committee in terms of its rigor, in terms of its fairness. I have seen in other committees where the convener tries to schedule vote at some midnight time so that they could slant the vote in some way. It's not as, I thought I was shocked, but this is something that I think we have to be impressed about the fact how we've been able to handle it.
I don't stay up that late. That's not true either. Gavi?
Oh, yeah. I guess my opinions have changed based on the rhythm of work. When I started, we used to have this Sunday meeting, the one where you have Sunday nights and something, and then Herb quickly changed that to something more, civilized. The things that, for me, there are 2 things that changed and things that remain the same. When I went in, I was relatively young and easily impressed. And I thought that you needed to pass some kind of bar exam. When you're a lawyer, you have bar exam, but that was not the case. Anybody who was present in the room could make an opinion and take part of the vote. So that was something that I think is really, really good. Like, make it democratic. And as I tried to push things through the committee, I went through frustrations. And over the years, what I observed and changed my view was that those people, they're not there to frustrate me. They are very much committed to the highest interest of the community that we serve. And that blew me away. And I hope we continue to hold that, because it is, in my view, in my career, the only place where you have these things where no matter who they are working for, where they come from, there is this shared purpose of we have a community to serve. And I don't care about where you come from. That thing is the most important, the community that we serve.
I'm just going to follow up with a bit of a question that I had, because it's maybe a little related and also on welcoming this. I have been impressed that we regularly, for a long time, have had guests, had observers, new guests. At every committee meeting, we have dozens of new people who've never been there before. Some just want to see how things are done. They have a particular interest in a particular proposal. But something that we never tried, we never aimed for, but that has surprised me, is that for the last 2 years, every single CppCon, this conference right here, and every single standards meeting has had a local high school send a class. We had a high school class here from the Denver area yesterday, and they may be coming back during the week. That is, we're regularly having teenagers, and that is an awesome thing. Have you observed that? Any thoughts about what is encouraging that?
Oh, I love that. Like, so we had that in Hawaii, the last meeting in Hawaii. We had it in Tokyo. I found it like great. Like, I hope we don't stop doing it.
So to kind of, I'm new to the committee. I just joined like about a year ago. I pretty much agree a lot with what Michael said. But I will say this, specifically on the rigor side. I think the committee is very rigorous, and I expected that, but it was nice to actually see that. But I think the thing that's really changed for me is that when you go from outside, you see the committee as like this authority, and you don't really humanize authorities. And then you go in and you start meeting them, and you're like, oh, these are all just people. And in general, side note, the committee, I don't think I've met a person on the committee who I did not at least like or think was interesting or nice, or at least was welcoming and encouraging, which is really awesome. So to me, the thing that's changed in my mind when it comes to the committee is seeing them as a human organization.
Did I miss a hand? Excellent. Great question. Thank you.
As I said, I've been serving for 10 years, but I think with every meeting I go to, the comprehension of privilege to serve has grown, because we are making such a massive difference to the universe, and that's I couldn't have found that anywhere else. So I'm delighted to serve. Thank you.
Thank you.
Thank you. And our final question from the floor.
Okay, so I come from the country of Edgar Dijkstra. He and I share an IJK in our last name, and I'm at his last university. I see a certain tendency in language development, for instance, functional analysis, C++ is adopting that, ranges instead of loops that are impossible to analyze by a compiler. So elimination of undefined behavior. I see a certain tendency of the language becoming more formally analyzable. So is there an explicit awareness of formal methods, or is it purely coincidence that the language is starting to become more mathematical? Maybe that's one for you, Herb.
Oh, I won't answer it, but we have mathematicians up here.
There's one mathematician over there and one over here.
Yeah.
So we'll start over there.
Yes.
At least 2 trained mathematicians here.
There's definitely an awareness of formal methods. There's also an awareness of practicality and and sometimes there is an awareness of how to thread the needle between those things. But yes, I am very deeply committed to more formal methods, but there's some of these features aren't even coming from that direction. It's just that if somebody comes up with an easier way to think about things, even if they're not thinking in formal terms, they're just saying, yeah, this is easier to express this way than that way. And often I think it's really the formal methods that need to catch up with, these are the things that we find easy to express in programs, and we should bring our mathematics up to that level.
Yeah, so in a previous life, I used to do formal methods for a living. And as a matter of fact, I actually work with colleagues to prove that the thing that we hold dear resource acquisition is initialization is actually probably sound with respect to the C++ semantics. So that was a paper that we published at Purple in 2012. And before that, the work that I did with my colleagues were proving that the Athenium ABI object layout is also formally sound. Like it's proven, the algorithm is proven to be correct through, formal methods. One thing that I'll tell you, and I had some other ideas like proving that exception handling is also, formally sound. But one thing that was quite clear was if that is the minimum bar, the bar we set for standardization, we will leave a lot of people who have to contribute. We'll leave them out. So formalization is something that we should keep in the background. And a few of us just need to keep the community honest. But for a language that is used by a vast number of people, 10 millions of people, I think it will be a disservice to require formal methods as the basic thing. Like just look in academia, how many of these formal method students, PhD students we have? Not that much. Like they're not even a fraction that you count in the measuring error to compared to the C++ population. So yes, the community is aware of formal methods, but more so like a background thing, and then getting the ideas of people, and then a few people like Lisa and myself, like, hey, be careful, don't divide by 0 because that's really bad.
Andre?
I think there's also an organic aspect to it. Like consider it's a young métier, right? I mean, it's 1956 Fortran. They didn't know how to do commands, right? They didn't know that there was no formal method for anything they were doing. They literally had no idea what they were doing, right? So with time, it's an organic process. Like the good formalisms are going to percolate into the language, and it's as simple as that. And it takes 10 years for something in research to. By the way, I read your 2012 paper, loved it. So it just takes years, for 10 years on average, for some research to make it into practice. And to the extent they're good, they're gonna just make it organically.
I'm going to make one comment myself. A lot of the best improvements that we have made and are making have, and I said this yesterday, have been enabling programmers to directly express their intent. A range for loop, visit every element in the range rather than the for int I equals. You're directly expressing your intent, and you mentioned several of those examples. The more you do that, the more information is in the program, the more analyzable it is, and that is what enables the formal methods to naturally work because they use the same information. But even more than helping the formal methods is it helps the human communicate with the compiler and have the program do the right thing. It happens to also let tools understand the program better too. So thank you for that question.
It's sort of correlation without causation.
Yeah, there's an overlap, yes. Mm-hmm. Fellow travelers through the night. So thank you very much for that. I will just go over by a couple of minutes to get a very short answer from each panelist to round up. And my question for each of you, and maybe we'll start with Mike and then work our way through the reverse way this time at the end to wrap up. After all, reverse order of initialization and destruction. Is what proposal would you like to see in the near to medium future in C++ that isn't currently active? There hasn't been a proposal, or maybe there was one, but it's not currently active. Anything come to mind?
So I actually had a question after last night's panel that actually asked about that. And it really comes from something that you talked about, which is intention-based programming. I really, really want something that is telling people what you want to do, as opposed to what most programming languages do today, which is how to do it. That is a big reach, and I don't think any proposals we have will totally cut it. But I think it's doable for us.
I think today in our practice of programming in C++ and the standardization, there's a huge gap between what we use, the tools, and the specification of the language, because the way we specify things today is, well, we have this abstract language that runs on this abstract machine. And what I would like to see, I don't think there is a proposal today, is reduction of that gap between the tools that we use, like formalize the protocols of the tools that we use, and the language itself. That doesn't mean we want to have one influent compiler. Just means that we can have as many as we want, but if they are all following the same protocol, then we'll increase portability, which is really something we want.
By the way, and that is in the spirit of how we standardize, which is to standardize interface, not implementation. Andrei.
A packaging system.
Yes.
Yeah, I'm way more short term. They're missing things for stood execution, so scope and task and maybe a thread pool.
So similar packages, but mostly CPS, the common package specification. But also, I'm a kind of a simple guy. We have in-place vector. I'd like in-place string. It doesn't exist yet. People ask me to maybe write that paper. Maybe at some point I'll write it, but yeah.
So I'm going to go back to something I worked on and then had to drop earlier in, I don't know, 2019. I'd really like to have a designated mechanism for communicating non-semantic or extra-semantic properties through generic library layers. For giving hinting would be the kind of more common term. I don't know where that's going, and I mean, maybe I do have time for that now, but we'll find out. But I think that that's something that's really missing from C++, and I think it fills a niche. Is missing from a lot of languages, to be clear, but I think it fills a niche in the complex library ecosystems that we have that I don't really see people talking about a lot, but I often see people talking about, I wish we had a way to say this.
So I'm going to also go back to something that I worked on in Drop. We had a question about this earlier. It's like we have these things in the language where like we don't really know how to talk about bytes, and I used to do lots of like low-level, real-time, low-latency stuff where you do lots of bit fiddling, and we just have so many holes in the object model for like making that work. Like we had some good progress. JF had this paper bitcast, so now you can do like bitcast, and Richard Smith did the implicit lifetime types. So now you can cast something to an object and it springs to life. But there's so many more of these holes, like one I mentioned earlier, look at the bytes of an object. There's other holes with like arrays, like you can't really look at an array and a struct that has, it has the same layout, but there's lots of these bit fiddly things where we have holes in the object model. And I'd really, really love to fix all of those so we can talk about objects and bytes and actually make stuff not UB that people are doing. But that requires more time than I have because I got sucked into this whole contracts thing now. But I wish we could finish that work and actually have a solid understanding of how we look at bytes, because a lot of low-level code needs to do that, and it would be great if that wasn't all UB, which it kind of is today.
And Lisa, final word.
Okay, I'm afraid I'm going to stretch this out a little bit because it's complicated. Those of you who have followed my talks know that I have worked a lot on function interfaces, and that's fed into how contracts work to some extent. And this this past year, I returned to a problem that Alex Stepanov posed to me ages ago of looking at object and type interfaces. And there's a riff on that connects to the paper I had to write for function interfaces on function pointers that's currently in the process, won't make it for 26, maybe 29. And when you put all of that together and look at object interfaces, you end up with something that has a strange resemblance to concept maps. And that's a feature that everybody wanted and nobody could ever figure out how to make work. So no promises, but maybe there's another stab at that in the future.
That's an excellent place to land all of those observations. Thank you. let me thank all the panelists and also thank all of you for staying. We hope you found it useful. Shall we have a round of applause for the panelists? Thank you very much.